Welcome to springlib.
We want to use some kind of CAS software to graph the function f of x is equal to 3 over 3 plus 2 sine of x, and use this software to find the first, second derivatives, graph those as well, and then estimate the intervals where the function is increasing, decreasing, intervals of concavity, and find any extreme values and points of inflection. So I went ahead and graphed f of x here. And if you were to really zoom out further along the x-axis, you would see that this is really periodic, and it has this same shape that repeats over and over again. So, which makes sense because we have sine of x, and we know sine of x is periodic. So, for what we have here, it's going to repeat like this every pi interval. So, if we go ahead and just describe this over the interval negative 3 pi halves to pi half, we know we can go ahead and just shift our interval by pi each time, and it will give us our new intervals where the function is increasing and decreasing in any concavity. So let's just go ahead up here and write period of this is going to be pi. So we know we need to add plus pi k every time. All right, now I went ahead and already graphed f prime of x here. And again, since I know it's going to be periodic and repeat between negative 3 pi halves to pi halves, I just went ahead and graphed only that part there. So let's figure out where this function is increasing on this interval. So remember, we know f prime of x greater than 0 is when the function will increase. So that looks like it's going to be from negative 3 pi halves to negative pi half. And then we can go ahead and transform this if we add plus pi k on each end to give us negative 3 pi half plus pi k to negative pi half plus pi k. And remember, k should just be some integer value. So remember, integers are 0, 1, 2, 3, 4, and negative 1, 2, 3, 4, and so on. All right, now let's go ahead and find where f prime of x is strictly less than 0, or where it's going to be decreasing on this interval here. So we're going to end up with, so it looks like it becomes negative at negative pi half, and it'll stay negative until pi half. And on that interval, that's the only place where f prime of x is strictly less than 0. So we're going to do the same thing that we did before. Add pi k to each of our n pieces, so plus pi k. And that'll give us the new interval of negative pi half plus pi k, and pi half plus pi k. And again, k is just some element of the integers. All right, so we know where the function is always increasing and decreasing. So now let's figure out if these are going to be local maxes or local mins. So over here at negative 3 pi halves, to the left of it, the function is decreasing because f prime of x is less than 0. And to the right of it is going to be increasing because f prime of x is positive. So that means at this point here, we're going to have a local min. At negative pi half, well, it is increasing into the point and then decreasing after it. So this is going to be a local max. And for pi half over here, well, it should match up with what we have at negative 3 pi halves because it is going to be periodic. So to the left, it is decreasing. To the right, it is increasing. So here we have a local min. And we can write this a little bit more generally if we want. So I'm going to call this here the local max 1. So we know we have a local max at x is equal to negative pi half plus pi k. And our local mins, local min at x is equal to, and I'm just going to use the right endpoint here, negative pi half, or just negative pi half, not negative, and plus pi k. And if I were to do k is equal to negative 1, I would get our other point here. All right, so we know where the function is increasing and decreasing for all these intervals, and we know where all the local maxes and local mins will occur at. Now let's go ahead to our second derivative so we can find points of inflection as well as any point where the function is increasing or any points of inflection and where the function is concave up and concave down. So I went ahead and graphed that interval once again. And so let's first figure out where the interval for our period that we're working with will be positive and negative, and then we can see if we can generalize it from there. So remember, f double prime of x strictly larger than 0 tells us our function is going to be concave up, and at least on negative 3 pi halves to pi half, that's going to occur at, so we're going to include our endpoint this time, so negative 3 pi half to, well, our first x-intercept, which is negative 2.124. And this we're going to exclude because f prime of x is not strictly larger than 0 there. And then we're going to union this with, from our next x-intercept, negative 1.017, until the end of our period, which is pi half. And we want to include our endpoint here. All right, so if we were to go ahead and do the same thing that we did before, we can go ahead and write this as, so we still want to shift it by pi. So let's add plus pi k. So plus pi k. And that's going to give us negative 3 pi halves, including the endpoint, plus pi k to negative 2.124 plus pi k, and then we exclude that endpoint, and then we union it with negative 1.017, add pi k to that. Now let me go ahead and zoom out a little bit. And then pi half plus pi k. And then remember this again. K is just some arbitrary integer. So any of these intervals here will be where the function is concave up. And if you wanted, you could try to find some nice way to combine these endpoints here. Oh, and this should be a bracket on the end here since we are including pi half, since at that point it's still increasing. You could try to find some nice way to make this just one interval if you really wanted to, but I would say let's just go ahead and leave it like this here. All right. Now we can go ahead and find where f prime of x is going to be strictly less than 0 on this interval here, which is going to be concave down. And for us, that only will occur on negative 2.124 to negative 1.017. And just like before, we're going to add the plus pi k so we can find all of our intervals. And that's going to give us negative 2.124, negative 1.017. Oh, almost forgot to put the plus pi k right here, plus pi k, and then negative 1.017 plus pi k, and k is just some element of the integers. And so this tells us all of our intervals where the function is going to be concave down. All right. And now let's find our points of inflection. So on this interval here, we have our x-intercepts at negative 2.124. So to the left of this, the function is going to be concave up. To the right, it's going to be concave down. So we have this change in concavity. So this will be a point of inflection. And our other x-intercept here, well, it's concave down to the left, concave up to the right. So this will also be a point of inflection. So we could go ahead and write this more generally as, so this first point of inflection here is going to be negative 2.124 plus pi k. And our other point of inflection, negative 1.017 plus pi k. And again, k is just some element of the integers. So this describes all of our points of inflection, and we have our two intervals here for where it's going to be concave up and concave down. So we found all points of inflection where the function is always concave up, concave down, all extreme values, and all intervals where the function is increasing and decreasing. So we've done everything we needed to do.